Dr. Manis here talking to you about stoichiometry. This is where we left off last time. In our previous video, we talked about two-step and three-step conversion problems. For that, one step. So we have all the different types of conversions already. And the whole idea was we didn't make it, they were just one conversion to product. Now we're going to make it just a little bit more complicated already. And to make it just a little bit more complicated and a little bit more fun, to be honest, for me, okay? Let's flip that equation. Instead of aluminum oxide to aluminum and oxygen, let's make the aluminum oxide from aluminum and oxygen. What if you had both reactants and you wanted to convert them to product? You would assume that you need all of this, the 4, to react with all of that to make product. Cool? Alrighty. And that 4:3 ratio is called a stoichiometric ratio. If they're reacting in their stoichiometric ratio, if they're present in the stoichiometric ratio, that means you got the mole ratio of 4:3. If that happens, then you would make 2 moles of aluminum oxide, if they were in the right ratio. Okay? What if instead, let's just not use some 0.00247 moles. Let's just say instead of 4 moles aluminum, what if we only had 3 moles with 3 moles of oxygen? Could that reaction still happen? Sure, it would still happen. But the thing is, you don't have enough aluminum to react all the oxygen. Okay, you always need just a little bit more, like 1.33 or whatever it is, 1.25. You need a little bit more aluminum than you do oxygen. Well, now we don't have enough aluminum. So the aluminum is going to run out. We're going to have leftover oxygen. Alrighty, what if instead, let me change the numbers up a bit. What if instead we had, I don't know, say 40 moles of aluminum, but we only had 20 moles of oxygen? Okay, well, that's not in the 4:3 ratio, is it? It looks like we don't have enough oxygen to use up to react all that aluminum. So the aluminum is going to be in what we call excess, and the oxygen is going to be what we call limiting, because the oxygen will actually limit the progress of the reaction, because the oxygen is going to run out first. And that's where stoichiometry gets interesting and more practical. In chemistry, we often have these things called limiting reactants and excess reactant. The limiting reactant is one that runs out first. It limits the amount of product you can make. Okay? The excess reactant has some left over. So we're going to have a couple of calculations here. We got to figure out, how do you know which one's limiting and excess? And then how can I get my amount of product that I can make, my stoichiometry calculation? And then often we would kind of want to know how much of the excess is left over. Okay, so let's just get into some examples here, and it'll elucidate itself. Okay, when you want to get limiting reactant, you have to account for how much of each you got. Like in this groovy little example, we got 0.025 moles of nitrogen reacted with 0.070 moles of hydrogen. You know you got to do limiting reactant and not a straightforward conversion, because now we have 2 givens. Okay, so if that was like in your problem, you got to go through this route. Alrighty, a lot of students will just immediately look at it and say, hey, I got less of the nitrogen, so that's going to be my limiting reactant. That's going to be excess. And you're wrong. Okay. Face it. All right, you didn't account for the fact that we need 1 nitrogen to 3 hydrogens. You have to account for how much of it you need. You have to account for the ratio. Alrighty, so accounting for the ratio, alrighty, 0.025 divided by 1 gets us 0.025, but 0.07 divided by 3 gets us 0.023. So hydrogen's actually present in the smallest amount based upon the stoichiometric ratios. Okay, and then if you look, the units are canceling, so we have answers that don't have any units, and that's kind of cool. Okay, so the next thing you're going to be asked is, well, how much product do you make? Well, if you're going to determine the moles of ammonia produced, the ammonia produced is going to be based upon the limiting reactant. Okay, so there's 2 things you could do. You could say, screw this, I'm just going to convert that to product through a 1-step conversion. And there's a second way. The first way is right here, the 1-step conversion that we've done before in previous videos. This is new. Or is it? If you look, 0.070 divided by 3 is right there, because that's over 1, and that is what you did right there. So some students look at that and go, I already know that part, 0.023. If I just multiply by the coefficient, then I can introduce the right units. I still have an equality, and I'm good to go. So whichever way you want to do it, the red way or the green way, it doesn't really matter to me. It's just the same thing, okay? Just depends upon your own point of view, your own preference, alrighty? So you can convert to product from the limiting reactant. Some teachers say, well, to make the moles of ammonia produced, you convert both of them to product and see which one's least, because the limiting reactant makes the least. And you can do that, but I would really advise not to do that, to follow this methodology, because this can branch out in all the rest of your general chemistry, first and second semester general chem, and other things that you have to do by knowing the limit reactant. Alrighty? Like for instance, in the next one, we want to get the moles of excess reagent remaining. Okay, well, you know nitrogen was the excess and hydrogen was the limiting reactant. Okay, now let me just really quickly give you this analogy. You have $40. Okay, you spent 30. How much money did you have extra? You would say it's 40 minus 30 is 10. I got $10 left over extra. Same gig here. How many moles of excess reagent do you have? Well, how much did you have in the beginning? You know, how much did you have at the start? How much did you use? That's your extra. Like your 40 bucks, you use 30, extra is 10. Well, how do you know how much you're going to use? Well, convert moles of limiting reactant to moles of the excess, and that will tell you how much you're going to use. So let's just see that. All right, because H2 is limiting reactant, N2 is the excess, let's convert that. This says 0.023 moles of nitrogen would react with limiting reactant. Well, we had 0.025 moles. That's what we started with. This is how much we used. That's the difference. So you'd have 0.002 moles of nitrogen left over. Alrighty. These are all multiple step problems. You don't have to see all the fine detail of each problem, which is where I think a lot of students get caught up. Just get an idea of the path you want to take and let the details fill in as you go. Remember, focus on units, not numbers, and life will be good. Alrighty. Hope you like it. Hope you love it. And I hope you take care. Have a good time. I'll talk to you later.